In this video, we are going to look at some examples of the addition properties, the subtraction properties, the multiplication property, and the division property. As you learned in class, one of the addition properties says that if a segment is added to two congruent segments, then the sums are congruent. In looking at this example, I can see from the diagram, because of the tick marks, that segment AB is congruent to segment CD. Now I could add this segment BC to segment AB, and I would have this longer segment AC. I could also add segment BC to segment CD to get this longer segment BD. So I have this segment BC right here being added to two segments that are congruent, AB and CD, which allows me to say that AC is congruent to BD by the addition property. If you would prefer to write out the entire property instead of just saying that this is the addition property, you are more than welcome to do that, but you can just say this is the addition property. This next example is very similar to the first example, except this one deals with angles. So looking at this diagram, I see that angle EFJ is congruent to angle GFH. And I have this angle JFH, which is congruent to itself by the reflexive property. So if I add angle JFH to angle EFJ, then I have angle EFH. And if I add angle JFH to angle HFG, then I create a larger angle JFG. And I know that angle EFH is congruent to angle JFG by the addition property, or because if an angle is added to two congruent angles, then the sums are congruent. In this next example, I'm also going to be using the addition property to prove that two segments are congruent, but this is slightly different than the previous examples. This addition property states that if congruent segments are added to congruent segments, then the sums are congruent. In this example, I have that segment BC is congruent to segment FE, and also that segment CD is congruent to segment AF. So I have two congruent segments and another pair of congruent segments, and when I add those, I'm going to get congruent sums. So BD will be congruent to AE by the addition property. I could do a similar example with congruent angles being added to congruent angles, resulting in larger congruent angles. But I'm going to move on to do some examples relating to the subtraction property at this point. Okay, this first example of the subtraction property gives me segment AD with points on it B and C, and I'm told that segment AC is congruent to segment BD. Now if I look at this, I can see that both of these larger segments contain the segment BC, which I've highlighted in blue. If I remove that segment from each of the larger segments, AC and BD, I am left with segment AB and segment CD. And by the subtraction property, because I have subtracted this segment BC, then I can conclude segment AB is congruent to CD, because if a segment is subtracted from congruent segments, then the differences are congruent. If you would prefer, you can just say that segment AB is congruent to segment CD by the subtraction property. What you want to notice that this is different from the addition property, because in this case we have longer segments being congruent, and we are taking out or removing or subtracting a part of those segments to result in smaller segments being congruent. This is another example of the subtraction property, except in this one we're not looking at an angle being subtracted from congruent angles resulting in differences being congruent. We're looking at congruent angles being subtracted from congruent angles. So I'm given that angle ABC, which is this large angle here, is congruent to angle EFG, which is this large angle here. And I'm also told that angle ABD, this angle here, is congruent to angle EFH, which is this angle here. So because I have two large angles congruent to each other, and two parts of those larger angles being congruent to each other, I can basically remove those angles ABD and EFH, and I will be left with angle DBC, which will be congruent to angle HFG. Angle DBC is congruent to angle HFG by the subtraction property. And again, if you prefer to write out the subtraction property completely, you can say that if congruent angles are subtracted from congruent angles, then the differences are congruent, or you can just say that these angles would be congruent by the subtraction property. Just a reminder, when you have bigger angles or segments being congruent and you are trying to prove something about smaller angles or segments, you'll be using the subtraction property because you're going from big to small. And when you have smaller angles or segments congruent and you need to prove something about bigger angles or segments congruent, you'll be using the addition property because you're going from something small to something larger, and the way you get from something small to something bigger is by adding. Good luck!